Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. This is continuation under May June 2022 question paper. So we're gonna do question 9, which deals with cubic functions. So let's just dive into it. It says the sketch below is the graph of f of x. It is equal to x cubed plus ax squared plus bx plus c. Now, do you agree with me that the value of a it is equal to 1 here? Okay. Here, actually, the value here, we have a value of 1 here, right? Yes. So the x-intercept of f are at 3 and 0 here, and m here, all right? Where m lies on the negative x-axis, so the x coordinate here should be negative, all right? K0 and -3 is the y-intercept. We have the y-intercept here. Then M and N are the turning points of F. M and N are the turning points of M. Now, before we move on to one thing, anywhere actually, can you realize that M is a turning point as well as an intercept at the same time? Can you see that? M is a turning point and an x-intercept. Now, what I like to tell my student about this whole part. Now that M acts as both a x-intercept and a turning point, the equation that you use to find this equation, it is like this. It is x y it is equal to, let me say, a into x minus x1 squared. You have to square this part because now the values that you get here are both for what, for the turning point as well as x-intercept. Now, sometimes if you are given a full equation and they say determine intercept, you are going to realize that your answer is going to be -1, x it is equal to -1, x it is equal to 3. Sorry, if you are required to find x-intercept of a particular function and you realize that you have x it is equal to -1, x it is equal to -1, and x is equal to 3. This one that are repeating itself, they tell you that these coordinates, one will act as an x-intercept as well as the other one will act as a turning point. So it means it will intersect maybe like this, maybe like this here. It also acts as a turning point as well as x-intercept, or this particular shape thereof that you have here. Okay? Yes. So now that's what I wanted to clarify. Okay, let's see what the question requires. Oh, here, not only this, but you also have another x-intercept. Remember, you have how many of them? You have 3. So it is 2 because there is this squared here, right? But it is the same, therefore the other one. Okay, therefore let's just see 9.1. 9.1 says, show that the equation of f, it is given by this much. Now, before I forget, many students struggle to get these questions that are like this, but it's fine if you struggle to move on to other questions. You will use this thing, they will never penalize you. You will use this equation there to calculate whatever this what you are required to calculate thereof, but you should know how to calculate this. So please do not leave this question unattempted after failing to get 9.1. 9.2 will use the very same equation, they will never change it. All right, unless the examiner now is starting to become more smarter. All right, 9.1 says show that the equation is given by that, right? So we have to collect as much data as we possibly can. We should collect data as much as we possibly can. Now, the first thing that I can see is that I have this point here. This point, it is what? Y-intercept. And I know for y-intercept, I let x equal to 0. So I can come to this equation here and say, all right, let me say y it is equal to what? Or what is y in this case? In this case, I'm given y as -3. So I'm going to say y it is equal to -3. It is equal to, when I see x, I substitute how much? 0 cubed plus a into 0 squared plus b into 0 plus c. Therefore, you all agree with me that this one will become 0. Therefore, c it is equal to -3. Now we have one one man down, negative 3, one man down. Okay, now that we have one negative 3, what can we do again? Let's see. What do we have? We have the x-intercept, all right? The x-intercept, we only have one intercept, x-intercept. Then you do not have any turning point, but it's fine. We can, and now we know the gradient. The gradient for this equation, it is 1. It is positive, right? The gradient, it is positive. So I can say, I come here and say, remember the formula that I showed you earlier. All right. So instead of saying 1, I'm going to say m so that you can see. Let me say x1 actually, it's fine. So this will be x1, then this will be my x2. Why am I saying x1 should be squared? Because I repeat it, x as both the turning point and the x-intercept. So I should square it. Now I'm going to say, I'm going to substitute any point that I have on the graph for y and this x. This x and this x are the same, okay? Yes. This x and that x are the same. So I'm going to take this point and substitute it there. So if I substitute that point there, it's going to be negative 3, it is equal to, I said a, what is the value of a? The value of a is not this one. This one refers to the gradient. So how much is our gradient there? Our gradient in this case, it is a, it is equal to 1. All right, our gradient, it is 1. So I'm going to say, oh, here's my gradient. I'm going to say this is 1. X, what is x? X is 0. This is your y, this is your x that you're going to substitute. 0 minus, do we know the x coordinate here? No. Just leave it as xm. All right, squared. What is x? X, it is 0. Minus what is x2? X2, it is positive 3. All right. Then I solve 0 minus 3, it is negative 3. Then I divide by negative 3 on both sides. It's going to be 1. It is equal to this multiplied by this is the same as, what is negative? Xm to the power, xm to the power of 2. You agree with me? It's going to be xm squared. All right. Then I can take a square root on both sides. Take square root on both sides. When I do so, I get that xm, it is equal to plus or minus what? 1. Remember, everything that comes out of a square root, it is either positive or negative. Or you can do this. You can say xm squared, instead x squared minus 1, it is equal to 0. You know it is x minus 1, x plus 1. So still the same thing. All right. Then, but x coordinate of m should be, they told that it lies on the negative x-axis, so it is negative 1. All right. Now that we know that xm, it is negative 1, let's collect this. Xm, it is negative 1 here. We know that this is now negative 1 here. Let me put it underneath. Negative 1 here. We can say, all right, we can now go back to our equation and say y, it is equal to x, the same equation, but now we are doing what? We are substituting. All right, there is also an a here, there is also an a there, which I know it is equal to 1. Then when I'm going to do this, I'm going to say x minus, what is x1? X1, I now substitute negative 1. All right, squared. Then x, what is x3? X3, it is x2, it is 3 rather. Okay, this is me substituting here. As I continue further with my calculations, what is x? This is x plus 1. You all agree with me? X plus 1 squared is going to be x squared plus 2x x plus 1, then multiply by x minus 3. Then I have y, it is equal to, I distribute now. I distribute and do my algebra. So it's going to be, when you have reached this stage, your final answer will be the same as that one that you were asked to prove. Okay, which is equal to negative x squared plus 5x minus 3. Therefore, this is your final answer. Okay, yes. So that's the analogy that you are supposed to to follow to in attempting this question. And it will be best that you start attempting these questions first on your own before doing before actually watching the video. Okay, so that you can realize where you have done your mistakes. Okay, so let's move on to 5.9.2. 9.2. Calculate the coordinates of n. N, what is n? N is our turning point, and we know at our turning point. We know at our turning point. I've also stated this in question 6. We know that our turning point here at the turning point, the gradient, which is our derivative, it is equal to 0. We know here the derivative it is equal to 0. The graph is neither increasing or decreasing, but rather at stationary. If you are doing physics, you know when something it is at stationary, it is not moving. All right. So its gradient it is 0 here. So every time when they want the coordinate of n, which is our turning point, you're gonna say in that point f of x should equal to 0. What is f of x? We're gonna derive this equation a. All right. You're gonna derive that equation and say, all right, and maybe I can do it here. First thing, I'm going to say f of x it is equal to 0. What is f of x? It is 3x squared. You now know rules, right? 2x minus 5 it is equal to 0. Then it's a matter of you doing your math here. I don't know how you do it, but please do it your way. Negative 2, 3 multiplied by negative 5, negative 15. Then factors of 15, 5, and 3. Then negative divided by 3 by 3. I get x plus 1 as well as 3x minus 5. It is equal to 0. Therefore, I get that x it is equal to negative 1 or x it is equal to 5 divided by 3. But I already know that at x it is equal to 1, I have a turning point and it's here. And I know its corresponding y value it is how much? It is 0. So I'm not interested in this one. I'm not interested in this one. Instead, I want of m. So we agree this one, it is the coordinate x coordinate of m. This one, it is the x coordinate of n, right? So I'm only interested in this one because they say calculate the coordinates of n, right? Yes, already this one we have. So I'm gonna substitute this x coordinate to the original equation. So I'm gonna say 5 divided by f of x when x it is equal to 5 divided by 3 is gonna be how much? I'm gonna substitute 5 divided by 3 cubed minus 5 divided by 3 squared minus 5 into 5 divided by 3 minus 3. Please do a neat substitution there. Let's quickly punch that on our calculator. 5 divided by 3 cubed minus 5 divided by 3 squared minus 5 divided by negative 5 into 5 divided by 3 minus 3. So I get something like negative 256 divided by 27. All right, yes, just leave your answer as it is. Now, in terms of coordinates, I'm going to want this in terms of coordinates. Therefore, it's going to be what? N is going to be, what was x? X was positive 5 divided by 3, right? What was my y? My y was negative 256 divided by 27. All right, this is what I get. This is what I get. All right, let me erase this then now. 5.7 says, for which values of x will what f of x be less than 0? These questions, I like to translate it like this. F of x, it basically says to us, sorry, f of x is less than 0 where our graph is below 0. All right, below x, below x axis. All right, where is our graph below the x axis? Now, when we check, From this point, please take note of this. This is very important. From this point, it is below, right? It is below, it is below, it is below, it is below, it is below. But at M, it is not below, it is exactly at zero. So I have to skip that point and come back from here to here, still below, still below, still below, still below, still below. But when I reach this point, before reaching 3, I should stop because at 3, it is not below, it is exactly at 0. So now, how do I write this? I'm going to say, please watch me. Please watch me closely. I'm going to say it starts from negative infinity until it goes to negative 1. From negative infinity to negative 1. Then it stops. Then it continues again from negative 1 to 2 to 3. This is what you are supposed to write. Say from negative infinity, I see my graph, but at negative 1, it does not, it is not decreasing, or it is not below rather, right? Then from negative 1 going to 3, it is below, but that negative 1, I should not include it. I use this to include negative 1. Or someone might say, all right, I see it is from negative infinity. Actually, let me write it this here. One might say, all right, I see it is from negative infinity to 3. My graph it is below, right? From negative infinity to 3. But my x should not equal to negative 1 because why? At x it is equal to negative 1. My graph is not below, it is rather equal to 0. All right? It is neither below or above. So this you can write it like this. All right? So let me write this answer here. One might say, all right, as I was saying, the first one can say from negative infinity to negative 1 or from negative 1 to 3. Do not include that. The second one might come and say, now I prefer writing it like this and saying, I know it's going to be x should be less than negative 1 because from negative 1 going to that side, which is less than this sign, less than negative 1, I can see there that my graph is below, or my graph between 3 and negative 1 there. Between negative 1 and 3, my graph it is also below, but I do not include what? This negative. Why? I do not include the values of x. Why? Because the interval says strictly less than, not equal to. All right. Then someone, I don't know, that who can think like this and can say, I can see my graph from negative infinity to 3. It is below, but my x should not equal to negative 1. All right. These are the 3 ways of writing it. Preferably, I'd prefer these 2. All right. Yes. So I believe I answered that question. 5.5, 9. But where do I take this 5? 9.3.2 says, for which values of x will f be increasing? Let me erase this. Will f be increasing? F is our graph. Where is it increasing? Check from negative infinity to 1 to negative 1. Remember, at the turning point, our graph is not increasing or decreasing. It is strictly at stationary. So we do not include this point in negative 1. So it is from negative infinity to negative 1. But that negative 1, it is excluded. Then in this portion, it is decreasing. But from here to that point, it is increasing. But take note, at n, it is not increasing or decreasing, it is at stationary. So it means one might say from negative infinity to negative 1, but you do not include negative 1. Why? Because it is not increasing. The memo likes to say, or one might say negative infinity to negative 1. No, this is absolutely wrong. Absolutely wrong. Why? Because now at x it is equal to negative 1, our graph it is at stationary. Here, can you check? At this point, it is not increasing or decreasing. Hence, we are saying our gradient it is 0. It is not increasing or decreasing. Hence, we cannot include this sign here, this bracket here. This is absolutely wrong from a perspective of physical science. Okay. Then also here, I cannot include this point. Why? Because at that point, my gradient it is equal to 0. I do not have my gradient, my graph here, it is neither decreasing or decreasing. Neither increasing or decreasing. It is at stationary. So therefore, I'm gonna say from this point, x coordinate of this one, which is 5 divided by 3, to what? To infinity. My graph, it is increasing. Memo does has an option that says 5 divided by 3 to infinity. This is absolutely wrong. This is wrong. I cannot include 5 divided by 3. Why? Because now it is at stationary. So at stationary, it is neither increasing or decreasing. So the correct answers there, it is from negative infinity to negative 1, which is excluded, or from 5 divided by 3 to what? Negative 256 divided by 27. Okay? Or someone preferring another interval can say x should be less than negative 1, or x should be between 5 divided by 3 as well as negative 256 divided by 27. This should be your answers for 2 marks. All right. Now the last 9.3.3 says where f a determine the values of x. For which values of x will f be concave up? Now when they talk about concavity, what should come to your mind first? What should come to your mind first is that your derivative, your second derivative. All right, you're gonna derive your equation twice. Your second derivative should equal to 0. Your point of inflection should be somewhere here. Remember, for concavity, we look at the point of inflection somewhere between here. It is a point between what? It is a point between the two turning points. This is what we call the what? Point of inflection, or inflection point. So let's see how much is our point of inflection. You're gonna double derive. It is equal to 0. Remember, for turning point, you say f prime x is equal to 0. But for point of inflection, you say what? Second derivative should equal to 0. All right? Yes. So let's find the coordinate of the point of inflection there. For concavity, we only need the x coordinate here. So it's gonna be I know I've already derived. Remember, f prime x, it is equal to 3x squared minus 2x minus 5. So when I double derive that, it's gonna be 6x minus x. We are lying. 6x minus 2, it is equal to, really? Let me see. All right. It is equal to 2 is equal to 0. Something is not giving. Vibes. 3x squared minus 2x minus 5, it is the first principle, the first derivative. The second derivative should be x squared minus 2. It is equal to 0. Therefore, x should equal to how much? X should equal to, or when I take this to the other side, it's going to be 2 divided by 2, right? Then 2 divided by 6, it is 1/3. So the x coordinate here, and it is, I'm correct to say it is somewhere here, because now it is how much? 1/3. 1/3, it is 0.3333333. So you all agree with me, it's somewhere there, right? Then I do not know the y value. What I'm interested in only, it is what? The x coordinate here, which is how much? 1 divided by 3. Right? Now, where is it concave up from this point? You all agree with me, this is concave up. It is facing upwards. Smiling face, it is concave up. So this position, it is concave up. From where? From the point of inflection going to that side. You all agree with me? I'm giving you an answer. From the point of inflection going to the right, you see what? You concave up. So as you answer this question, you're gonna say from, therefore, concave up should be greater than 1/3. Let me write it this neatly. Therefore, for concave up, x should be greater than 1 divided by 3. Why? Because I'm saying as you move towards the right, which is greater than, it is concave up. But if they wanted concave up, it was going to be from this point of inflection to that side, which is less than. So it was going to be x less than 1/3. But in this case, they ask for what? For concave up. It is that answer, the off. All right. What's important is you getting the point, saying the point of second derivative it is equal to 0, adding the x value there, then to 0. Actually this, then concluding. All right, yes. Then let's see how much time I have for this all right, so again I'm gonna continue 9.4 on another video. Please understand this, because I want you to get full marks when you write your exam. So the questions that needs time and better understanding, I will continue them in the next video if necessary. So please follow up on the next video and when I do 9.4.